Righto, morning folks. Today we're going to learn about parametric equations. Fun times. So let's imagine a scenario where there's some just flat ground and a cricket player is hitting a cricket ball, or a cannon is firing a cannonball. We've got something that's projecting a ball from this point here up through the air and landing down over there. Okay. Now we're going to imagine two views of this scenario here. So in our first view, we've got somebody over here looking directly straight in that way. Okay. In our second view, we've got somebody way up high looking down on the scenario. Okay. What would the different views be like? What would this person up here see? So they're up the top and they're looking straight down. What would they see? Well, they'd see the ball fly across, straight across. They wouldn't necessarily have any perspective of the ball coming up and down like we do. If they're directly on top of it, all they'd see is the ball starting here and ending up over there. Right? So they'd see only horizontal motion. What about the person who's looking at it from this side over here, like coming straight in from side on? What would they see? Well, all they'd see, if there was a ball flying directly to you, okay, again, ignore the parallax, right? The camera kind of like zooms into my finger. My finger's small here and it gets bigger out there. But if you were far enough away so that you couldn't have that sort of zooming effect of the camera, what would you see? Well, you'd see my finger going up and down. Okay, so I'll try to stand back a little bit further so you don't get that, and then all you see is my finger going up and down. But if I was to turn side on, my finger's actually going sort of backwards and forwards. I'll turn the other way so you can actually see that a little clearer. So my finger's going in that sort of parabolic arc. Okay, but from front on or from side on, all you see is my finger going up and down. Okay, so the different views would give different perspectives of exactly the same motion. So, I mean, there is some people have done the work, so we're not going to reinvent the wheel here. What they actually find is hello.
Morning. Who are we talking to?
We're talking to Year 11 Extension 1.
Nice. You're just filming it?
I am.
Oh, he's not really talking to them.
Well, no, I am. I'm filming it.
No, but you're not talking to them. Talking at them.
I'm talking at them. Yes. Well, so nothing's different, is it, guys? Nothing's different. Righto. So like I was saying, the work has already been done for us. Okay, so we know how parabolas are described in this way. And by the way, when a ball is projected from one point to another, when it's thrown through the air, the Greek word for that is parabola. It literally means a flying or a thrown ball. Okay, that's what the word parabola means. As I was saying, sorry, I was getting over that little distraction then. These equations, so the equation that we just see in the horizontal and the equation that we just see in the vertical, these have already been discovered for us. We're not going to reinvent that wheel now. Okay. So what do we know? We know that horizontally, x equals 2t and y equals t squared. And that gives us a parabola. So the y equals t squared is describing the up and down motion, and the x equals 2t describes the horizontal motion. Let's see what we can do with that. So in other words, let me sort of take a step back. The x equals 2t is describing what we see horizontally. So for every moment of time, t, that passes, the ball has travelled a certain distance. Okay. little bit of physics. I mean, I know that a lot of you guys do physics, but a little bit of physics revision or a little bit of introductory physics for those who don't. The only thing that can change the motion of an object is a force. So I'm standing perfectly still here. Nothing can actually move me unless a force acts on me. So for me to move, if I was going to walk towards the camera, I'd have to be flexing some muscles, in other words, applying a force to move. I can, if I was to sort of squat down, nothing's going to make me go up unless I apply a force down on the ground to make me stand up. Okay, so nothing changes motion except for a force. If I've got a ball being thrown through the air, or a pen lid, as the case may be, if I've got something being thrown through the air like that, the only force acting on it when it's sort of here in the motion, the only force that acts there is the force of gravity. That's the only force, and gravity only goes straight down. So horizontally, there's no like sort of pushing force that way or retarding force back the other way against the motion. So the only force that acts on the pen lid is the force of gravity that goes straight down. So if there's no force horizontally, that means that the lid's horizontal motion stays as it is. Now I'm ignoring air resistance, of course, a little bit of air resistance, but for the purposes of our model, we're going to ignore air resistance. I always laughed in physics exam questions when they say, a plane flies overhead and drops a package, like describe the path of the package, etc. And they say ignore air resistance. And of course, if there's no air resistance, the plane couldn't fly, but I digress. So that's why this expression for x is a linear expression. There's nothing changing the motion of horizontally. There's nothing changing the motion of our parabola as we throw the ball through the air or as we launch the cannonball through the air. Okay, so if there's nothing changing the motion, then horizontally it's going to be a linear thing. There's nothing makes it go faster or slower, so that's why we see this linear expression here. Vertically, of course, well, we've got a force that acts there, and the force that acts there is gravity. Gravity accelerates. I'm not going to do a physics thing now, but that acceleration, look, I'd need to borrow something from further ahead in the course in calculus for us to see exactly why it's a power of 2. But suffice it to say for now, you need to just take my word for it. We will see when we do projectile motion in the future. But for now, we're just going to say, we're just going to take Mr. Obeid's word for it, that acceleration is variable. So the speed of this guy is always changing. From the second it leaves my hand to the second it returns, its speed is always changing. It's at its fastest the instant it leaves. It stops at the top and it speeds up again on the way down. So really quick, slowing down, stopped, speeding up, and then at its maximum speed at the bottom of the motion. So that's why we got that. That's a non-linear expression for y. Why that particular one, we'll get to later on. So what can we do with these parametric representations? So what we say here is that x and y are described or defined parametrically by the variable t. So t is called the parameter, and x and y are defined in terms of the parameter t. So the word, just for posterity, so we've got the word recorded. T is the parameter. So it's one variable that changes, and its change affects both x and y. So the person looking from above at our projection, as time passes, they see a change in horizontal distance. The person looking from side on, as time passes, they see a change in vertical distance. So x changes as t changes, and y changes as t changes. Now, is there a relationship between the two? Well, there's kind of got to be, because they're both looking at the same projection, right? In both cases, they're both looking at the same ball that was shot from over here that ends up landing over here. So because they're both looking at the same physical phenomenon, well, there's got to be some kind of connection. And the connection, of course, is that it's the same time that is passing in both. So it's not like the ball goes from, from over here to over here, and then at some point later in time, the ball goes from here, from here to up here. So it's doing the horizontal and the vertical at the same time. Okay. So what can we do with this? Well, we can eliminate the parameter. So you get that word eliminate. It's exactly the same thing as we do when we use the elimination method for simultaneous equations. So consider these two equations simultaneously. I can eliminate the parameter t. So, for example, I can say from equation 1, t is equal to x over 2. Okay. In other words, I can substitute this into equation 2, where I say y equals x over 2 squared. In other words, y equals x squared on 4. Or we're going to discover a new way to write yet another general form. So another general form for a parabola, we say that x squared equals 4y. That's a very, very quick introduction to parametric equations with parabolas. I'm going to do another one in just a moment to speak about parametric representations of. Actually, no. Look, you know what? I'll wait for you guys to actually make a start on exercise 5H, and I'll get you guys to have a look, and then you see what you find in that exercise that maybe gives you some pause or some questions or some thought, and then shoot me those questions, and that will guide the follow-up videos that I do to this. So exercise 5H, have fun, get into it. Good on you guys. Questions either in the comments below or on our Microsoft Teams page.